All right, let's look at these human body systems. When we look at one, the first one that we'll look at is the musculoskeletal system. When you look at medical terminology, they use these vowels, O-A-E-I-O-U, okay, thanks. And vowels to connect, so they're connecting words. Musco, or muscles, skeletal. So musculoskeletal is the muscles and the bones. Fortunately for you guys, we don't spend any time memorizing the bones. Muscles. There's 600 and something. All right, I'll leave that up to your anatomy and physiology teacher later in life. You can hate them instead of me for all that. But there's a lot of muscles, and you memorize all of them. Depending on what profession you go in, a lot of you have to keep those in your head. I memorized them long enough to take the test and get out of class. And then I started forgetting all those muscles. One, those Latins, they just crazy people. They don't know how to name anything where Texans can pronounce it, okay? I understand a lot of the terminology because when they were doing this, when they were dissecting people, it was considered witchcraft. And they'd burn you at the stake for that. It was totally outside the social norm to cut somebody's body open after that. So when they looked at that, they named it terms that, like what they saw, when they looked at it. So what the musculoskeletal system does for us, it gives us shape. Can you imagine without bones what we'd be? Man, glad. We'd just muscle and fat laying on the ground. Then we'd have a problem with locomotion. We wouldn't be able to move. So it gives us form and it gives us locomotion. And then the rib cage, and a lot of it protects our vital organs. Without the rib cage, probably nobody, especially football players, nobody would survive. Because it exposes all your vital organs. Your liver and your spleen, your kidneys, all your heart, all your vital organs are tucked up underneath the rib cage. And ribs are very hard to fracture or break. So let's look at here's some more bones. I won't hold you responsible for these bones of the face yet. I'm just throwing them up there so you can see them. All right. We'll make this the skull for right now. There's different parts of the skull. Like the side of the skull is the parietal region. The back of the skull, the occipital region. Right here, the temporal region of it. The temporal artery and temporal vein is there. Temporal nerve as well. This upper cheek here is called the zygomatic bones. The upper jawbone, the one that doesn't move, the maxilla, and then the movable jawbone, the mandible. And then around here, you have the nasal bones and the orbit. Notice how all these bones interconnect in the eye socket or the orbit. When we get into trauma, we'll talk about facial fractures. Man, those are some cool facial fractures. When those things they fragment like glass. And you get these huge, huge fractures in the face. But go ahead and commit those to memory. That way you get ahead. But probably won't be tested on them anytime soon. I want you to look at this. And we will refer back to this cross-section of this guy's face, head, a lot. Because it displays a lot of important anatomy. When you start looking here, you have the nasal passage. These structures here that look like swollen passages in there are called turbinates. The reason that the purpose of those turbinates are to warm the air so we don't breathe in cold air. So when you breathe in your nose, adults are nose breathers, so we breathe in through our nose, it warms the air before it goes down the trachea. You have the oral passage with the mouth. These are prominent because later we're going to be putting things in here. So you have to know those two cavities. As we go down, once we start into CPR, you have this flap. Everybody see this flap right here? That leaf top structure, leaf flap, is called the epiglottis. Without the epiglottis, every time that we would drink water or swallow food, we'd risk our lives. Because what the epiglottis does, every time we swallow food or water, that epiglottis covers the opening to the vocal cords or our trachea. If we didn't have that, then every time we took a drink of water, we would risk that water going down the trachea instead of the esophagus. And you get water in your lungs, it's a bad thing. We'll talk about that bad thing later, but not now. So you get down through here. Anterior would be the trachea. So as you go down below the epiglottis, it feeds into the trachea. The esophagus, or where your food should go, is the posterior. So you have two openings. You have the opening to the esophagus and the opening to the trachea. The trachea is anterior to the esophagus. The esophagus is posterior. This right here is your spinal cord. This is the vertebra in your neck. As we shift over here, this is your spinal cord. The spinal cord runs up through the middle of the spinal column. We'll get to that, the spinal cord and the column, in a little while. But it runs up through there, protecting the vertebra. The spinal column protects the spinal cord. And we all know what happens if you damage your spinal cord, right? You get paralysis of some sort. As this works up through this hole that's in the bottom of the skull, which will play a prominent role later when we start talking about head injuries and swelling and things, it comes up through there, and this small structure right here, it's called the brainstem. The brainstem controls all your vegetative functions. Respirations, body temperature to a point. I mean, it's got some help from another gland in the brain, but all your vegetative functions mean everything that you need to live. You've heard of that term that I never want to hear you guys say, that a patient's a vegetable. That means that they've had an injury to their brainstem. So all your vegetative functions are controlled here. We will break that down into great detail later, because part of the respiratory system is in here, on the medulla. Y'all have seen Waterboy? Yeah. The medulla oblongata. Well, on the medulla is a structure called the pons, P-O-N-S, and on the pons there's two respiratory centers. And those two respiratory centers allow us to breathe in and out from the brainstem point of view. So you have the brainstem, right sort of posterior. Throwing those medical terms down. Posterior to the brainstem is the cerebellum, which I call the small brain. The cerebellum controls all your fine motor skills, like starting an IV, threading a needle, doing fine motor skills with your hand. All your fine motor skills are controlled through your cerebellum. Your cerebrum, or the big brain, controls all your gross motor skills. And I don't mean gross like, oh, I'm about to throw up gross, right? Gross means big. So medical-wise, when you hear gross, it means big, something big. The same way acute, A-C-U-T-E, means suddenly. So acute onset means sudden. So gross means big, acute means sudden. So this is a good structure to look at. We'll flip back through here, and when we examine the brain a little bit more, we'll look at this cross-section again. Any questions there? Yes?
Doesn't your brain cells start dying when you go into cardiac arrest?
Your brain cells die every day. Your brain cells are dying right now. Your brain cells die at a rapid rate when you all the time, and they don't regenerate. Just lucky that we have a gazillion of them. But yes, you stop breathing, your brain cells start to die pretty quick due to the lack of oxygen, to answer your question. And then here's a real brain, the cross-section of that. Let me flip these lights off for you for a second so you can get really sleepy. So here's the spinal cord. The brain stem works up in here. Cerebellum, small brain. Cerebrum, big brain. If you notice this black spot right up in here, we'll refer back to this when we talk about strokes. This particular person had a stroke. Killed this portion of the brain back here. Then I think the next one is a full brain. They're holding it up. No, sorry. Maybe later. The next thing that we'll look at is the spinal column. Now the thing with the spinal column is it's divided into these sections. You'll have to memorize the sections for right now. So you have the cervical spine. You may hear a term called hold C-spine. C-spine or cervical spine. That just means you're holding someone's head still. So you hold C-spine. The cervical vertebrae are quite small, so a lot of neck injuries, a lot of high spinal cord injuries. The thoracic vertebrae are quite big. They're big, they're bulky, they're thick, so less fractures through here. Lumbar in the lower back, the sacrum and the coccyx are fused together. Anybody ever seen anybody with a coccyx fracture? Anybody ever have a broken tailbone in here? You notice them because they sit on a little donut.
I thought that's for people that have
hemorrhoids? Yeah, either you have hemorrhoids or a broken tailbone. You just can't put pressure on there. So it's very painful. You can't do anything. They don't make a butt cast, so they don't have anything to help that. It's just painful. It has to sort of repair itself. I definitely want you guys to memorize the different sections of the spinal column. Remember that the spinal column, we'll look at bones here. The spinal column and these vertebrae, see how these vertebrae stick out? And these parts here are called processes. These bones that stick out anywhere is called a process. So these are spinal processes. I think it's pronounced some other way, processes or something weird like that. But those people are not from Texas. So you have spinal processes, and then the spinal cord fits up in here, and it protects it. You can have a broken back without being in a wheelchair, correct? Because these someone that has that just means that they broke one of these processes. Have a spinal fracture, a vertebral fracture, with no spinal cord involvement. When we talk about spinal cord injuries later, we'll get into that. But the spinal cord sort of shoots up through there, and it's protected by these vertebrae around it. The spinal nerves go out through the holes in the vertebrae. So you have the spinal cord going down, you have spinal nerves that are going out through the vertebra. I'll have a dissection film that we'll watch that's really cool. It shows these, the spinal cord, and it shows all the spinal nerves. You have a whole bunch of spinal nerves. I don't know how many, but you have a whole bunch of them. And they sort of go out through the sides of the spinal column. And if someone may get a spinal cord injury, they could have temporary paralysis due to just swelling, and someone putting that swelling putting pressure on that spinal nerve that's going out. The only time that they would have permanent paralysis is the spinal cord got severed. So they haven't figured out yet how to fix spinal nerves, how to put them back together. They have problems with the sheath, the thing that goes around the spinal nerve. They can't figure out. It keeps coming apart. All right, any questions there on that part of the skeletal system? Everybody good? We'll shoot over this app now.